Okay, now, how do we combine empirical studies via numerical synthesis? Okay, so previously we have seen there are two strategies. Yeah, there are two kinds of synthesis of evidence. Right, the first one is numerical synthesis. The second one is narrative or descriptive synthesis. So when we use numerical synthesis, how do we combine the results? How do we combine the studies? So combining studies via numerical studies only applicable for quantitative studies. Okay, this is the first thing that you have to remember. Okay, numerical synthesis only applicable for quantitative studies, not qualitative studies. Right? So we are talking about empirical studies that are quantitative in nature. So how do we know that one study is quantitative? How do we know that one study is qualitative? The difference between quantitative and qualitative is just by numbers. Okay, numbers. It's very easy to detect. For example, if someone is conducting an experiment, okay, an experiment maybe measure maybe measure the quality of software. Okay, but quality of software is a bit subjective. Maybe you want to see um, how good certain methodology in improving students' grades. Okay, students' grades. So you can measure that quantitatively because students' grade you can spell out in percentage, for example. Okay. So here, in many empirical studies in software engineering mainly, okay, our aim is actually when we do empirical studies, we wanted to see if there is any effects. Okay, if it exists in the study's results. Okay, let's say for example, when we use one particular method or one particular tool, we wanted to see whether is there any improvement or not in the productivity, or is there any improvement or not in the software quality. So how do we know this? So we wanted to see the effect. The effect in the sense that when we introduce a new method or when we introduce a new tool, it will help increase productivity. Okay, so someone who says, who claim that, you must have evidence to show that yes, it is. This method is good because it helps increase productivity. Maybe in terms of save time to write the code. Yeah, so that increase productivity. So instead of spending 3 months, you can just spend maybe 1 month or 3 weeks to settle the coding, right? So maybe the new method introduced is very good. So how do we know that it is really good as being claimed? Right, so this is where in the empirical studies that conduct study, okay, about how effective certain technique or method or tool, they are aiming to see if there is really an effect. Okay, if there is any effect, if it exists. So as much as we want to confirm the existence of an effect, we also wanted to know the magnitude. Okay, this is one thing. Having an effect is one thing because people can always claim that we can see the differences. Maybe they have the hypothesis, and then eventually the results, supporting the alternative hypothesis. Okay, maybe when they conduct the studies and they found that the p-value is less than 0.05. Okay, and then they said that this is significant. Okay, so when something is significant, it is not necessarily that significant is strong enough for us to believe. This is what we call as the magnitude of the of the effect. Okay, the magnitude of the effect is what we call as effect size. Okay, is what we call as an effect size. So there are means to measure the effect size. Okay, the first one is by a standardized difference. Okay, this one, if let's say you want to compare study, maybe you want to compare two things, tool A and tool B, or method A and method B. So it has comparisons there. So you can calculate or you can compute the effect size, which is the magnitude of the effect. Okay, using the standardized difference. So this is by means of knowing the variance. Okay, so you can calculate for example, the means and standard deviations. We can also calculate effect size by means of association. Okay, for example, we can use the correlation coefficient. Alright, so we can use correlation coefficient as a measure of effect size. So effect size is an indicator of the average magnitude of an effect. Okay, this is what effect size is referring to. An indicator of the average magnitude of an effect. Okay, so for one particular study, okay, let's say when they conduct a study and they compare, let's say, between method A and method B, okay, and then the results, they can actually calculate the effect size, okay, to see how significant the effect is, the significance or not, right? Okay, now when we do the numerical synthesis, okay, the most common technique, the most common technique that people use is meta-analysis. Okay, this is one technique. Now, actually, numerical synthesis have a number of techniques like vote counting. Yeah, counting might means to just count how many, but that is not too convincing. Yeah, because counting, that can be biased as well because you just count. Another way to perform numerical synthesis is by meta-analysis. This is one of the proven technique. So what is meta-analysis? Meta-analysis is a statistical technique that can be used to pull data or to aggregate results from different studies. Okay, so the aim of meta-analysis is to combine, to aggregate results from multiple studies that are homogeneous in nature. You see here. So when we are talking about aggregating results, this is the keyword here. Okay, when we talk about meta-analysis, we are talking about how do we aggregate results. So when we want to aggregate results, we cannot compare apple and orange. Okay, so we have to compare apple and apple, or orange and orange. This is fair. So what it means here by different studies, there are different studies, but they are homogeneous. Homogeneous in the sense that, okay, all these studies are all talking about the same intervention, maybe pair programming. So there are 10 studies, all of these 10 studies talk about or investigated or run an experiment about pair programming. So that is fair enough because they are talking about the same intervention. Okay, they are actually investigating the same phenomena. All the 10 studies talking about pair programming. Or maybe you are concerning looking at translation application. So maybe there are I don't know, maybe less than 20 studies, yeah, that have studied about translation application. Okay, and maybe out of these 20 studies, only 5 of them maybe perform experiments. Okay, maybe they use maybe they are investigating one particular translation application and they perform exactly one experiment. Okay, so if let's say there are 5 studies on translation application, for example, then all of these 5 studies are performing experiments, of course, using different participants, but we can say these studies are homogeneous because they are talking about the same intervention, okay, or the same treatment, but using different subjects or different participants. That is expected because they are actually conducting the studies at different locations, probably. All right. So meta-analysis, the aim is to resolve uncertainty, okay, when the results of studies disagree, and to increase confidence in the results obtained from individual studies. And this is actually the expectation when people do meta-analysis. What we wanted to see actually, what we wanted to see. We wanted to see the bigger picture. Okay, if you notice that there are studies that are conflicting or disagree one another, so then we can have a look. What makes these studies disagree among each other? They are both looking at the same method, but they got different results. Okay, first study maybe says that the usage of the method is good. Another study says differently. Why is that so? Okay, so from the results of this meta-analysis, it can tell us how confident are we, okay, about believing or accepting, the results that the author is actually representing in their studies. Okay, so in order to use meta-analysis technique, we need to have a quantitative measure of each effect size. Effect size, here we are talking about effect size for every study. And when I say every study, I'm referring to quantitative studies, okay, and mostly experimental nature, experimental based study, right? Like for example, formal experiment or control experiment. So the outcome of a meta-analysis is an average effect size, okay, an average effect size. So because each study has their own effect size, so meta-analysis, remember, we are talking about aggregating results from different studies. So we are talking about and looking about how do we arrive at the average of effect size, okay, with an indication of how variable that effect size is between studies. So we wanted to see how various the results are, and the findings from each of the individual studies. So effect size is it can be calculated, according to Hedges or Cohen's approach. So we can calculate this effect size, that's why I said when you want to do a meta-analysis, you need to have a proper tool, for example, maybe you can use a CMA, comprehensive meta-analysis tool, software tool. I'm talking about software tool, or MIX, MIX. There are a number of tools that people have developed to calculate or to measure the effect size in meta-analysis. All right. So meta-analysis involves 3 main steps. Okay, there are 3 main steps. Okay, the first step is we have to first decide which studies. Remember, we cannot include studies that are not homogeneous. Okay, we only consider studies that are quantitative and homogeneous. So we have to decide which studies to be included in the meta-analysis. That's number 1. Secondly, we have to estimate the effect size for each individual study, right? So this number 2 is a bit challenging, because why I'm saying it's challenging. In most studies, from my experience, normally authors did not care or did not bother to report the effect size. This is a problem. I don't know why the authors, but actually this is an important piece of results. So we have to be transparent when we report the study findings. So if, let's say, the author did not say or did not report anything about effect size, it's our job, okay, as an analyst, as researchers, or as a person who wanted to perform a scientific review. Okay, it's our job to calculate, to estimate the effect size. And then thirdly is to combine the effect size. Okay, to combine the effect size from individual studies to get the average effect size, to get the estimates of the combined effect. Okay, so results of the meta-analysis can be presented in the form of forest plot. Right, so a forest plot presents the means and variance of the difference between treatments for each study. So we will see how can we visualize, okay, the finding, because we are talking about quantitative findings. So actually we can easily visualize it using a forest plot. Okay, this is what we're going to see next. Right, again, I mentioned to you that these are some of the software tools, but not all of these are actually open source. The one that I have used previously was MIX. This is free, as far as I know last time. I'm not sure now, but CMA is one of the best tools, most easiest tools to use, but unfortunately it's not free. And you can use R, you can use Theta, you can use OpenMeta, and many other tools. Okay,